The matrix of transformation. What is it? Well, we can create a matrix of transformation by determining how it operates on the basis. And in this example, we're going to look at how we can figure out exactly what this matrix of transformation is. So let's take a transformation here. And it's going to map from R2 into R3. And it will be a linear transformation. Defined by T of x being equal to x1 plus 2x2 minus x1 plus x2 and 2x1 minus x2. All right, so there's our linear transformation. And again, this is going to map R2 into R3. And in order to get or what we refer to as the matrix of transformation, essentially we rewrite this as a matrix product, if you will. So we want to rewrite as a matrix A times X, which is something that we're actually getting kind of used to, I think, at this point. And we can do that by pulling out the variables and just keeping the coefficients and writing it out as 1, 2, minus 1, 1, 2, minus 1 times the vector x. Again, x being an element of R2. So what we're left with as a coefficient matrix here is, in fact, what's referred to as the matrix of transformation. And in fact, we saw this early on in our first couple of examples, that we could view a transformation either in this form or as matrix multiplication. So we're just seeing that here, and now we're giving it an actual name. We're calling this matrix the matrix of transformation. At the beginning of this, I noted that the matrix of transformation can be determined by how it operates on the basis. So let's take a look at kind of how that works. And we'll do that just by looking at how it operates on the standard basis. E1, E2. Then here's what we get. T of 1, 0 is equal to, if we run it through, 1 minus 1, 2. And T of the other basis vector, 0, 1, is equal to 2, 1 minus 1. So that means that the matrix of transformation is what you get when you throw these two things together, which is 1 minus 1, 2, 2, 1, negative 1. And what we're supposed to recognize here should be the obvious, and that is that this matrix and this matrix are really the same. So when it comes down to it, when we're asked to find the matrix of transformation, we just grab that coefficient matrix. So in this way, we see that the transformation can be defined by how the transformation affects the standard basis.